And we want to be in an environment where we can learn the skills so that astronauts can go and plant the stars and stripes on Mars.
On May 26, 2026, NASA formally stunned the world by unveiling its ultimate architectural blueprint to establish humanity's first permanent off-world city. Moving far beyond temporary exploratory footprints, this newly declared space program outlines an aggressive strategy to colonize the hostile lunar South Pole. Through a rapid succession of privately funded and highly sophisticated robotic and human lander deployments, the agency is preparing to erect an extensive, decentralized network of habitation modules and advanced nuclear power grids. This historic master plan represents a monumental leap in long-term infrastructure development designed to conquer the freezing lunar wasteland. What they saw next would change everything we thought we knew. NASA is officially launching 3 foundational Moonbase missions designated Moonbase 1, Moonbase 2, and Moonbase 3, all firmly targeted to deploy by the end of 2026 to establish the core infrastructure of humanity's first permanent off-world outpost. To execute this rapid timeline, the agency is completely abandoning slow, traditional procurement models, declaring that it will no longer sit back and wait for industrial deliveries. Instead, leadership is dusting off the high-cadence, iterative operational playbook engineered during the 1960s Apollo era. This strategy sends an immediate demand signal to commercial aerospace markets to rapidly deliver automated landers, heavy rovers, and scientific instruments. By using this aggressive, step-by-step approach, NASA intends to master the science of survival and test critical machinery in the hostile lunar environment well before committing astronauts to long-term stays. The first spearhead of this plan is Moonbase 1, which will make history as the very first privately funded lunar lander mission. This historic operation will utilize the Blue Origin Mark I Endurance lander to deliver multiple payloads directly to the Shackleton Connecting Ridge, a highly strategic, ice-rich area located at the lunar South Pole. Structurally, this uncrewed spacecraft will carry 2 essential NASA scientific instruments, a specialized lunar retroreflector array and the SCALPS sensor suite. The primary objective of Moonbase 1 is to validate commercial landing precision and gather vital environmental data. Because Blue Origin shares core engineering systems across its vehicle lines, this automated flight will directly risk-reduce subsequent human landing system missions. According to official schedules, this pioneering mission is set to launch no earlier than the fall of 2026. Immediately following this initial touchdown, Moonbase 2 will execute the largest commercial payload delivery ever dispatched to the lunar surface. For this mission, the mid-sized astrobotic Griffin lander will transport an unprecedented cargo shipment exceeding 500 kilograms of pure technical infrastructure. The primary cargo on board is Astrolab's highly advanced lunar terrain vehicle, a heavy robotic rover engineered to master autonomous logistics and astronaut mobility. How would you feel watching a massive 1,000-kilogram autonomous machine touch down on an alien world, knowing it is carrying over 500 kilograms of pure industrial gear designed to reshape space exploration? This operation is critical to mature surface logistics, testing exactly how heavy machinery maneuvers through the abrasive regolith. Simultaneously, Moonbase 3 will deploy to expand our fundamental scientific understanding of the Moon through open competition. This mission will deliver the very first payload selected through NASA's PRISM initiative, a unique framework that unites elite universities, independent researchers, and commercial industry. The anchor scientific endeavor for this landing is Lunar Vertex, a highly specialized investigation focused entirely on studying enigmatic formations known as lunar swirls. These peculiar surface structures appear significantly brighter than their geological surroundings because localized magnetic anomalies somehow shield the soil from the eroding solar wind. Understanding how these swirls evolve will reveal how surface materials change over time and how future base infrastructure will withstand cosmic radiation. Highlighting the global scale of this grand return, Moonbase 3 will also integrate prominent international payloads from the European Space Agency and the South Korean Space Agency. proving that securing an off-world foothold is a truly international effort. To guarantee maximum operational redundancy, NASA is establishing a continuous data pipeline that links these 3 automated spearheads directly to flight operations in Houston. Every landing sequence, thermal reading, and mechanical stress calculation gathered from these initial deployments will update the agency's central digital twin model of the lunar South Pole. This allows engineers to predict structural wear on machinery before human crews ever arrive. Furthermore, by expanding the commercial payload capability through these initial 3 flights, the space agency is actively driving down the cost per kilogram for future orbital and lunar transport. This financial optimization is vital for igniting a self-sustaining lunar economy, ensuring that corporate stakeholders can reliably fund their own commercial outposts. By building this multi-layered framework, humanity is not merely launching isolated science experiments. We are systematically constructing the functional foundation for a permanent off-world civilization that will endure for generations to come. NASA has officially finalized the transport backbone for its surface mobility framework by awarding a massive logistics contract to Blue Origin to deliver its next-generation heavy rovers. Under this formalized aerospace agreement, Blue Origin will utilize its automated Mark I cargo lander product line to transport heavy equipment directly to the southern polar regolith. Each specialized delivery mission is valued at exactly $234 million. Beyond immediate cargo delivery, this uncrewed program serves a dual strategic purpose. By executing precise autonomous touchdowns, the Mark I lander series directly validates the core propulsion and navigation architectures required for the upcoming Mark II crewed landing vehicle. This systematic approach ensures that commercial guidance systems are completely risk-reduced before human lives depend on them. Furthermore, the space agency confirmed that this exact same Mark I lander configuration will be responsible for transporting the highly anticipated Volatiles Investigating Polar Exploration rover, known as Viper, to the lunar ice zones in the fall of 2027. To enable comprehensive surface Thom-Hearm and maximize physical reach, NASA has simultaneously authorized 2 separate development contracts valued at $220 million each for the first crew lunar vehicles. These heavy-duty platforms graduate far beyond the basic rovers used during historical 20th century space Thom-Hearm, combining autonomous robotic intelligence with human pilot mobility. The first major technical asset selected under this initiative is the Flex vehicle, engineered by Astrolab. The standout innovation of the Flex architecture lies in its ingenious compressed chassis engineering, which allows the entire 1,000-kilogram system to compress structurally into a highly compact volume to fit precisely within standard commercial lander payload fairings. Once deployed on the ground, this machine boasts full telerobotically operated capabilities, allowing flight controllers in Houston to guide its operations alongside a highly advanced autonomous driving suite. Structurally, the Flex vehicle has a maximum total mass of 950 kilograms, can comfortably accommodate up to 2 crew members in full pressure suits, and is legally rated to achieve maximum operational speeds of 10 kilometers per hour. To build this sophisticated machine, Astrolab is actively relying on top-tier aerospace subcontractors, including Odyssey Space Research for flight safety software, Axiom Space for human-machine interface integration, and Interloon for resource processing compatibility. The second critical surface mobile platform is the Pegasus vehicle, developed by the engineering teams at Lunar Outpost. The Pegasus architecture represents a highly streamlined, weight-optimized variant derived directly from Lunar Outpost's iconic Eagle lunar terrain vehicle design. This weight reduction is crucial, allowing the rover to integrate seamlessly with earlier automated commercial lander flight paths. The defining technological feature of the Pegasus platform is its real-time autonomous terrain mapping system, which utilizes a suite of laser sensors to scan the local topography at millimeter precision. By generating instant topological models, Pegasus can independently identify structural hazards, navigate treacherous fields of volcanic glass, and actively pinpoint the safest geographic coordinates for erecting permanent base infrastructure. Lunar Outpost is accelerating the development of this platform by partnering with automotive and defense industry giants, utilizing General Motors for advanced chassis dynamics, Leidos for deep space communication systems, and Goodyear for non-pneumatic durable tires that withstand the razor-sharp regolith. During the official briefing, Acting Director for Surface Mobility, Robert Pickle, detailed the strict engineering protocols governing the deployment of these heavy assets. Deep space telemetry models show that massive descent vehicles like SpaceX's Starship or Blue Origin's Blue Moon Mark II generate immense plume surface interaction, kicked up by thousands of pounds of thruster energy. This interaction shoots high-velocity dust particles across the vacuum, creating an artificial cloud capable of sandblasting nearby equipment. To mitigate this hazard, NASA engineering rules dictate a mandatory baseline separation zone, requiring these rovers to land or park a minimum of 2 kilometers away from active crewed BiDAP. Once deployed at this safe distance, the vehicles will autonomously traverse the rugged terrain to retrieve arriving astronauts. Are you willing to wait at a lonely outpost 2 kilometers away in the freezing dark, watching a giant rocket land on the horizon while an autonomous machine drives over the hills to rescue you? Both the Flex and Pegasus systems are structurally rated to survive the extreme thermal gradients of the South Pole, enabling them to execute continuous operations and traverse a grand total of 400 kilometers throughout their operational life cycles. This expanded distance capability provides an unprecedented operational range, ensuring that future science teams can securely unlock the deepest mysteries of this alien world. NASA's structural strategy incorporates an advanced robotic scouting fleet to master local geography well before human boots touch the ground. This specific initiative relies on Project Moonfall, a highly sophisticated autonomous drone network developed entirely by the Jet Propulsion Laboratory. To transport these newly engineered robotic platforms from Earth into lunar orbit, the space agency has officially awarded a critical transport contract to Firefly Aerospace. Under this formalized logistics agreement, Firefly Aerospace will engineer a specialized variant of its Elytra dark orbital vehicle for this specific mission. The engineering backbone of this first vehicle is built on the exact same structural systems that successfully landed and captured mind-blowing video of reaching the surface during the Eclipse Blue Ghost mission that successfully landed last year. Working directly with the Jet Propulsion Laboratory, Firefly Aerospace will execute the crucial phase called the cruise, deorbit, and braking stage. The Elytra vehicle will transport the drones from Earth directly into lunar orbit, slow down systematically, and at a specific altitude, safely deploy 3 or 4 independent drone units. These automated machines then take the mission into their own hands, managing their independent descent paths to land approximately 1 mile apart from each other. The primary engineering objective of this autonomous drone network is to validate extreme mobile technology under the unique southern polar lighting conditions and treacherous terrain features. Each robotic platform is fully equipped with advanced survive-the-night technology, which allows its sensitive electronic components to withstand the Tonkock freezing temperatures of the prolonged lunar night. Once the long night concludes and the solar arrays absorb sunlight again, the machines reboot autonomously to serve a permanent objective wherever they ended up. Project Moonfall will completely revolutionize planetary mapping by scanning and analyzing the surface at an unprecedented centimeter-scale resolution, vastly improving upon existing orbital databases that only provide a 1-meter scale resolution. By collecting high-resolution imagery across all mission phases, including deployment, landing, and nominal hopping operations, the drones reveal soil mechanics and local lighting conditions with incredible ground truth accuracy. Furthermore, by deploying localized retroreflectors where they land, the drones establish a highly accurate geodetic framework for navigation. This framework provides active landing beacons that provide a tremendous capability for precision landing for whatever human landing system or cargo spacecraft is coming into that area later. Beyond structural mapping, these autonomous drones possess deep subsurface prospecting capabilities to identify vital natural resources necessary for long-term survival. Operating across tens of kilometers, each drone uses penetrating scientific instruments to search for signs of water ice hidden deep within the subsurface. The sensors can effectively look into the surface of the Moon about 1 meter in depth, mapping the underground distribution of volatiles. Finding these water ice reservoirs is absolutely critical for the future base architecture, as this resource will eventually be mined to provide life support consumables and raw materials for fuel production. Additionally, before NASA sends other heavy assets or human crews to the surface, the Project Moonfall drones will continuously characterize the ambient radiation environment. This step helps engineers accurately predict how future materials and electronics will perform under constant exposure to solar particle events and cosmic rays. The final strategic objective of Project Moonfall is to establish a functional moon-based perimeter on the surface by placing 3 or 4 lunar drones at the strategic corners of the intended exploration zone. NASA can give them a critical multi-use function. By coupling the Survive the Night technology with advanced transceivers, these drones will effectively become the first lunar cell towers in history. Because future operations will deploy many assets on the surface, including automated rovers, habitat modules, and crewed vehicles, the total amount of bandwidth requirements will be exceptionally high. The space agency must ensure a continuous high-speed data stream to monitor real-time operations without experiencing signal drops. These localized cell towers will independently manage the communication network around the base, collecting massive data packets from nearby machinery and relaying them back to orbital observation satellites. Have you ever considered how terrifying it would be to walk into a permanently shadowed crater, knowing your only lifeline is a robotic cell tower sitting on a hill miles away? This local quantum net completely solves the problem of bandwidth choking, allowing for the uninterrupted transmission of high-definition imagery and real-time telemetry straight back to flight controllers in Houston. By integrating Survive the Night engineering, centimeter-scale geodetic mapping, deep resource prospecting, and localized telecommunication networking into a single automated package, Project Moonfall creates a protective digital grid over the South Pole. This mission proves that Phase 1 of the Moonbase program is an active demonstration of capability. NASA is systematically leveraging these automated hopping platforms to build a comprehensive, high-reliability database of the lunar environment. The ground truth data gathered by these drones will allow engineers to modify the design of future habitats and heavy machinery, ensuring that when human beings finally arrive to build the permanent base, they will do so with maximum safety and operational efficiency. Through the power of these autonomous scouts, humanity is securely laying the digital foundation for an enduring civilization beyond Earth. The structural blueprint for establishing a long-term presence on the lunar surface completely shatters our traditional concept of a centralized city. According to official architectural assessments presented by Chief Architect Nujude Moranci, there is absolutely no single geographic coordinate on the Moon that can simultaneously satisfy all planetary exploration and human survival objectives. The brutal lunar topography and harsh environmental constraints dictate a highly fragmented layout. Consequently, the newly unveiled master plan outlines an extensive, decentralized urban network spanning hundreds of square miles across the rugged landscape of the southern polar region. This sprawling configuration is a mandatory engineering response to the hostile terrain, requiring different functional zones to be separated by vast distances to ensure the overall safety of the outpost. At the center of this off-world network is the Survival Hub, where human habitat modules are strategically placed to maximize natural resource consumption. Engineering models require astronaut living quarters to be erected strictly on the elevated tops of local hills and ridges. These high-altitude ridges receive near-continuous sunlight, which is absolutely vital for providing solar power to the central station batteries and maintaining stable thermal control inside the structures. However, directly contrasting with these sunlit residential zones are the industrial extraction sectors. The critical resource mining operations are scattered far below the ridges, positioned around the perimeters of deep, permanently shadowed craters. These dark impact depressions are heavily sought after because they contain rich deposits of water ice and volatile compounds, but their extreme depth isolates them entirely from the sunlit survival hubs. This geographical separation creates a serious logistical challenge, as automated cargo haulers must continuously navigate the treacherous elevation changes between the sunlit ridges and the frozen industrial mines. To power this massive infrastructure, NASA is implementing a specialized nuclear power infrastructure, but its deployment introduces an unsettling reality for the future inhabitants. The space agency is actively developing a new generation of fission surface power systems capable of producing a baseline output of 2 to 15 kilowatts of continuous electricity. These advanced nuclear reactors can eventually be scaled up to generate 20 kilowatts of power, coupled with hundreds of kilowatt-hours of automated energy storage capacity. However, because these reactors generate dangerous secondary ionizing radiation, strict safety regulations require the power grid to be isolated far away from human activity. NASA engineering protocols legally mandate that these nuclear power plants must be positioned at a minimum baseline distance of 1 kilometer or more away from the main habitat modules to establish a permanent radiation protection zone. This creates a stark, silent wasteland separating the sunlit residential ridge from the ticking atomic heart of the base, connected only by buried high-voltage cables. If an emergency occurs in the dead of night, would you be willing to put on a pressure suit and walk a full kilometer into a pitch-black nuclear isolation zone to fix a failing reactor? This decentralized setup means that a failure in one sector will require long-distance surface transit across an environment that is actively trying to destroy human life. The mathematics governing survival in this off-world environment are incredibly cruel and leave absolutely zero margin for mechanical error. Because the moon completely lacks a thick, protective atmosphere to moderate ambient energy, the surface experiences some of the most cruel thermal gradients in the known solar system. In areas exposed to direct sunlight, the local regolith heats up rapidly, reaching scorching temperatures of over 250 degrees Fahrenheit. Conversely, when a region rotates into the darkness of the lunar night, the temperature drops precipitously, falling well below -200 degrees Fahrenheit. This rapid, extreme cycling places immense structural stress on materials, causing metals to expand and contract violently, which can lead to catastrophic seal failures on pressure vessels. The situation becomes far more cruel inside the permanently shaded craters where the mining sectors operate. These deep depressions have been completely untouched by sunlight for millions and potentially billions of years. Inside these eternal shadows, temperatures drop to a cruelty -400 degrees Fahrenheit, a level of cold so intense that standard electronics freeze instantly and steel becomes as brittle as glass. Humans and machinery operating within these craters are cut off from solar energy, relying entirely on the distant nuclear power grid. Furthermore, without an atmospheric shield, the entire base perimeter is completely defenseless against cosmic dangers. The surface is constantly bombarded by high-energy cosmic rays, solar particle events, and an unending rain of micrometeorite impacts that strike the ground at hypersonic speeds. During the historic orbit of Artemis II, the crew witnessed sudden flashes of light cutting through the lunar shadow, confirming that small space rocks are continuously obliterating the surface. Without a thick blanket of air to burn up these incoming projectiles, any module or vehicle can be instantly punctured without warning. This is the cruel reality of decentralized urbanism on the moon. Humanity is not building a comfortable colony. We are systematically distributing essential survival resources across the devastated region, radiation-soaked wasteland, where a single power failure or a microscopic pressure leak means instant death in the freezing dark. The intensifying global push toward the lunar landscape introduces a silent, sophisticated geopolitical race between major spacefaring superpowers. During the official briefing, investigative journalist Kristen Fisher raised a critical question regarding international competitors actively targeting subsurface structures. Specifically, China has officially completed an intensive, month-long subterranean survival training program involving exactly 28 taikonauts. This special military and scientific initiative directly prepares their crews to identify, secure, and eventually occupy ancient underground lava tubes scattered across the lunar topography. These subterranean hollow structures, formed by ancient volcanic flows billions of years ago, represent the most valuable real estate on the Moon because they offer complete insulation from outer space hazards. Whichever nation permanently controls these underground passageways gains an immediate, massive strategic advantage over resource distribution. In direct response to these international developments, the head of the Artemis program, Dr. Lori Glaze, officially clarified NASA's long-standing technical counter-strategy. The space agency has quietly conducted deep geological assessments and radar mapping of lunar cave networks for many years. NASA considers these natural underground caverns to be the ultimate structural solution for advanced Phase 4 infrastructure development. The thick layer of solid basalt rock above a lava tube acts as an absolute natural shielding barrier. This geological blanket completely blocks destructive cosmic rays, solar particle events, and secondary ionizing radiation that constantly bombard sunlit surface stations. Furthermore, these underground pockets maintain a completely stable internal thermal baseline, entirely isolating fragile electronic systems and human habitats from the extreme temperature swings felt on the surface. By shifting critical long-term survival assets deep underground, humanity can securely operate an enduring base without relying on massive, heavy, artificial shielding materials shipped from Earth. However, moving human beings between these protective underground environments and active surface operations requires solving a critical biological problem. NASA Administrator Jared Isaacman and Dr. Lori Glaze detailed that future exploration templates require a very high cadence of extravehicular activities, commonly known as spacewalks. Unlike historical space station programs where astronauts prepare for an isolated spacewalk weeks in advance, lunar base personnel must exit and re-enter high-pressure modules multiple times over a span of just a few days. This high-frequency cycling introduces a fatal physiological hazard known as decompression sickness, which occurs when sudden pressure differential causes dangerous nitrogen gas bubbles to form directly inside an astronaut's bloodstream. If a life support suit experiences continuous pressure changes, the physical toll on the human body can lead to instant paralysis or death. To completely neutralize this hazard, biological researchers at the Johnson Space Center are actively finalizing the Exploration Atmosphere Protocol. This initiative completely redesigns the internal artificial air mix and ambient pressure settings inside the advanced shelter modules. By maintaining a specialized, low-pressure, high-oxygen internal environment that matches the exact physical operating parameters of the spacesuits, NASA can completely bypass the long, traditional pre-breathe gas cycles. This allows flight operations to safely maximize the time astronauts spend working outside on the surface while completely guaranteeing internal physiological safety. How would you feel sitting inside a tightly sealed high-pressure module, knowing that a single mathematical error in the oxygen mix could instantly trigger a fatal lung injury before you even open the airlock door? This complex atmospheric balancing act is a mandatory requirement to sustain a continuous, multi-day operational tempo off-world. Beyond solving immediate physical and biological limitations, NASA is simultaneously enforcing a strict international legal strategy to protect its extensive network of robotic and human assets. As autonomous rovers and hopping drones expand the base perimeter across hundreds of miles, the agency is actively implementing specialized safety zones. This legal framework is built directly upon the foundation of the modern Artemis Accords and the historical Outer Space Treaty of 1967. Under these international agreements, nations are legally required to operate with due regard and prevent harmful interference with the pre-existing hardware of other signatories. NASA intends to use these safety zones to establish clear geographic boundaries around its ice-rich mining coordinates, communication net towers, and sensitive landing sites. To ensure full compliance from non-Artemis Accord signatories, the space agency is explicitly demanding a strict policy of reciprocal behavior. NASA openly respects the placement of assets belonging to other sovereign nations on the lunar surface, but leadership legally expects the exact same non-interference protocols to be applied to American infrastructure in return. This legal containment strategy ensures that hostile actors cannot intentionally park heavy machinery nearby or deliberately interfere with sensitive data relay networks. By combining advanced subterranean cave exploration, specialized atmospheric biology, and rigid international non-interference laws, NASA is systematically creating a secure, multi-layered defensive shield around its lunar operations. This ensures that the grand return to the Moon remains a highly organized, legally protected endeavor as humanity transitions from early technology demonstrations to a permanent off-world civilization. The ultimate visualization of this grand architectural master plan requires us to look far beyond the immediate horizon of the lunar South Pole. When evaluating the immense financial capital, heavy corporate machinery, and complex robotic infrastructure deployed across the polar terrain, humanity must recognize the true nature of this journey. The Moon itself is not the final destination for our species. Instead, this entire decentralized network of automated rovers, nuclear reactors, and high-altitude habitats serves as a brutal Mars-proving ground. This cold, radiation-soaked world represents a vital planetary laboratory where our engineers can systematically learn how to interact with toxic, razor-sharp regolith and master the mechanics of operating nuclear power networks directly on an alien landscape. Executing these dangerous tech demonstrations on the Moon provides an invaluable safety buffer because the outpost remains a mere 4 days of travel away from emergency assistance on Earth. This close proximity allows NASA and its commercial partners to continuously stress-test survival systems and resolve catastrophic mechanical failures before attempting a journey across deep space. Venturing blindly into the void without validating our machinery under these harsh local constraints would be a suicidal endeavor, leaving future space travelers entirely helpless when their machinery inevitably fails months away from home. Consequently, the core operational focus of this entire lunar program is specifically engineered to master deep space survival technologies and achieve full resource self-sufficiency. The primary objective is to perfect advanced chemical techniques to extract buried water ice from the permanently shadowed craters and separate those frozen molecules into pure hydrogen and pure oxygen. Mastering this off-world chemical extraction allows logistics teams to manufacture high-energy rocket propellant directly on the lunar surface. By converting local resources into operational fuel, we can dramatically reduce the total cargo weight that future spaceships must transport out of Earth's heavy gravity well. This localized fuel production infrastructure effectively transforms the Moon into an active cosmic stepping stone, establishing the critical deep space refueling station necessary to power the next giant leap of our civilization. The structural knowledge accumulated through early automated landings and manned exploration loops was directly incorporated into the final development blueprint for deep space transport systems. By utilizing the Moon as an operational foundation, humanity is actively establishing the industrial stepping stones required to safely transport an expeditionary crew across millions of miles of empty vacuum, land them safely on the alien soil, and successfully plant the stars and stripes directly upon the red surface of Mars. This comprehensive architectural integration marks the definitive beginning of an unbroken evolutionary line for human civilization. When future generations look back at the historical logs of 2026, they will not merely see a collection of isolated aerospace contracts or robotic touchdowns. Instead, they will recognize this exact temporal window as the pivotal moment when humanity officially graduated from being a single-planet species into an enduring, multi-planetary collective. The early infrastructure established by the deployment of the Pegasus and Flex rovers, coupled with the autonomous perimeter grids of Project Moonfall, forms the literal bedrock upon which our descendants will erect massive industrial complexes. Over several decades, these early technology demonstrations will systematically evolve into self-sustaining biospheres expansive material manufacturing centers, and international research universities operating entirely off-world. The severe cold regolith that once represented an insurmountable graveyard for early spacecraft will become the foundation for a vibrant, multi-layered society, transforming our relationship with the cosmic environment forever. Every localized battery grid, buried high-voltage cable, and automated refueling hub constructed during this foundational era will serve as the structural model for future engineering projects on other distant planetary bodies across the solar system. Furthermore, this immense cosmic leap will trigger a profound shift in the collective consciousness of our species back on Earth. As deep space observation satellites and lunar cell towers maintain a continuous, high-bandwidth streaming loop of real-time surface operations, the daily sight of human machinery moving through the alien darkness will become completely normalized. Children growing up in this newly established era will no longer view space exploration as a distant, abstract dream reserved for a select group of military pilots. Instead, they will view the cities on the moon as an accessible, realistic extension of human geography, inspiring millions to pursue advanced careers in astrophysics, quantum mechanics, and planetary geology. This massive educational influx will accelerate technological breakthroughs that will directly improve the quality of human life back on our homeworld, generating efficient clean energy networks, advanced closed-loop recycling systems, and highly resilient structural materials designed to withstand extreme terrestrial climates. The industrial and intellectual capital generated by our struggles at the southern polar ridge will systematically reinforce our global economy, proving that the wealth of our civilization is no longer bound by the physical limits of a single planet. We are actively constructing a living bridge between the historical struggles of our past and the infinite potential of our future. By choosing to stay and master the science of survival in this freezing wasteland, we are guaranteeing that the light of human reason and consciousness will continue to illuminate the vast, silent dark of the cosmos for thousands of years to come. Standing on the precipice of this new cosmic era reminds us of our true position within the grand fabric of the cosmos. When we view these massive 1,000-kilogram rovers and complex docking modules against the backdrop of the lunar night, we are forced to confront an overwhelming epic perspective of human existence. In the grand scale of the cosmos, our entire civilization resides on a tiny, fragile blue body floating quietly through an immense, uncaring ocean of darkness. We are a young, vulnerable species trying to survive on a harsh, freezing frontier that is completely indifferent to our ambition. Yet, despite our profound physical insignificance and the extreme dangers of the void, humanity possesses an unyielding, resilient spirit that refuses to remain confined to our birthplace. We continuously look upward into the unknown, choosing to build complex machines, operate atomic power systems in the dark, and march boldly into the freezing wasteland because it is our fundamental nature to explore. Our mapping of the stars is not driven by a desire to conquer, but by an innate necessity to learn, to grow, and to understand the deep mechanisms governing our existence. Every automated landing sequence executed on the South Pole, and every breath drawn by an astronaut inside a pressurized habitat module represents a victorious strike against the cold stagnation of the vacuum. The universe isn't broken, our map of it is just incomplete. As we systematically assemble this extensive infrastructure across hundreds of miles of alien regolith, we are doing far more than constructing isolated scientific outposts. We are actively writing the opening chapter of humanity's permanent transition into a spacefaring civilization, ensuring that our collective knowledge and culture can endure across generations. This grand return is a testament to what we can achieve when global intelligence, corporate innovation, and political willpower unite to pursue the seemingly impossible. The long, silent night of the moon is finally being pierced by the lights of human machinery, and the foundational pathways to the planets are being securely cleared for the generations that will follow in our footsteps. What do you think? Does this change how you see our place in the cosmos? The journey to establish this first off-world foothold will undoubtedly challenge every technical limit we possess, but the rewards will echo through eternity as we push our civilization further into the great cosmic ocean. I'll keep exploring if there's more to uncover. Thank you for watching this deep dive into NASA's ultimate lunar master plan. Your support drives this journey into the cosmos. If you love space exploration and cinematic science documentaries, please hit the like button, subscribe to Cosmic Odyssey, and share your thoughts below. Until next time, keep looking at the stars.